Hello and welcome to part 2 of the ABAQUS tutorial. In part 1 we looked at modelling a masonry wall and subjecting it to a blast explosion. In this part we're going to look at how you can analyse the results in order to see how the wall responds under the blast explosion. So we can see that the job has been completed from the first part of the tutorial. So if you right click on the job and scroll down to results, and if you click on results, the visualization window shall appear. And in this video we can have a look at the response of the wall in more detail, and we can see how it is acting under the blast explosion. So there's many things that you can look at, but first of all we're going to look at the displacement. So if you go and click on U, and as you can see the displacement appears in the window. If that does appear straight away, if you just go back to the first view, now this is the start of the explosion, and as you can see in the top left hand corner we've got the displacements will show, the value of the displacement will show in that window. And if you click next, and we can see that initially in that window there, the displacements have populated, and on the wall itself, contours have appeared showing the various different displacements. And as you can see, as we proceed further on, the displacements tend to focus towards the center of the wall until about 0.0065 seconds, and we've got a circle of displacement in the middle of the wall of about 32 millimeters. And then as we progress further, the displacements start to go away from the central wall into two distinct sections. So as we can notice there, the main displacements are at the center of the wall. So what we're going to do is have a look at those in more detail. So we can do that by going to Tools, XY Data and Create, and then we're going to do ODB Field Output and click Continue. And what we're going to do, we're going to look at a particular node in the center of the wall. So we're going to select Unique Nodal, and then we're going to go down to Spatial Displacements. If you go down to Spatial Displacements and open up that menu, we'll see an option for Magnitude. Click on Magnitude and then go to Elements/Nodes. And we're going to do is delete section. We're going to create a new selection on the wall. So click Add Selection and select a node anywhere in the center of the wall there. So we're going to have a look at how that node is reacting under the time of the blast. We click Plot, and as we can see, a graph appears. So that's time versus displacement, and we can see at a time of about 0.0065 seconds. We get a maximum displacement. The displacement then begins to fall, and as the wall tends to return back to its original position, this is due to the wall being modelled as elastic. In reality, that sort of displacement of 30 millimeters would result in the wall maybe cracking, but as it's elastic, that's what's happening. And this is further emphasized by clicking on the Activate Cut view. Click on that and then watch the wall displacing again. We can see again as the displacement is starting to focus in the middle of the wall, and the wall itself begins to displace in the middle quite a lot, and then to a point of 0.0065 seconds, which you can see there at the bottom of the screen. And then as we continue, the wall now starts to return back to its original position. So this is giving us an idea of how the wall is behaving dynamically under the blast explosion. And the wall does return back, but not completely back to its original position. There is still some displacement at the end of the time period. And we can look at other things such as the stress on the wall. So there's a stress, but going back to the displacement, we can also view a animation. So if you go to Animate Time History, and then we can have an animation of how the wall is reacting under the blast explosion. So it just puts all the clips together, and then it shows you in the box there the displacements. And then you can see dynamically how the wall is behaving. And we can do this exact same thing for different things such as the maximum principal stress, the von Mises stress, the Tresca stress, in the exact same fashion, just selecting it from the menus, and we can see the response of the wall. So this is the end of the video, and this has shown how we can analyze the dynamic response of a masonry wall subjected to a blast explosion.